which of the following type of data is best represented by this figure? If you look at the question, there are two things. One is this figure, they didn't mention what kind of figure is this. Another one is we have to find out what kind of data is this. So given options were nominal, continuous and discrete. Okay, so we'll look into the figure now. First, we have to identify the type of figure. Basically, the confusion usually comes between two things. One is between histogram, another one is between bar chart. Okay, if you look at this diagram, there is no gap between each cell. For example, if you consider A, B, C, D, and E, there is no gap between any of these cells. Okay, in the same. So this is called histogram. If the same diagram, if there is gap between A and B and C, for example, if it is drawn like this, then it is called bar chart. Bar chart could be horizontal wise also, can be vertical also like this. Okay, so this is the basic difference and simple, easy to identify is this gap. Okay, if the gap is there, it is called bar chart. If no gap is there, then it is called histogram. So now coming to this one, now we got to identify which of the following type of data can be best represented by this histogram. Okay, now coming to the type of data, we know basically the data is of quality and quantity. So we have to find out which kind of this one. Okay, now we will see the what kind of data and variables are this one. Basically, data are classified into qualitative, as I said before. Another one is quantitative. Okay, quality, you know that it doesn't involve any numericals and it involves fully of numericals. Okay, this is the gross difference. For example, if they are asking the name of the patient, for example, name, gender, and smokers and non-smokers, the question is like whether you are smoking or non-smoking, then the answer will be yeah, I am so smoker or I am not a smoker. So it's like a mutually exclusive, the answers will be. So then it is called nominal. For example, I will give another example. So what is your name? So he says so and so XXX. Okay, he will say Y1Y. Okay, it like unordered categories which are mutually exclusive. For example, what is the religion? So he will say whether I am Hindu, Muslim, or Christian, whatever the thing. These are all the mutually exclusive things. Okay, so these kind of data, if they are collected, then it is called nominal data. Okay, now coming to this ordinal. Ordinal, you can easily remember like this: order, OO. Okay, here also nominal means name, nam, name. Okay. In Hindi, naam means name. So you can remember like this, like name. Mostly it will come under name, name of the religion, name of the guy, name of the girl, whether he is a gender, what kind of gender. Like these questions and all will come under nominal. Okay, order. Coming to the ordinal one. These are also mutually exclusive, but in the same sense, the category how they will divide in the sense like severe, moderate, mild. Like this, like it will range from one area to another, like mild to ascending to descending, like this one, like for example 1 2 3 4 5 IOTN values. Okay, this is index. These could be can also be asked in another MCQ, like IOTN index values can come under which kind of data, then we would say ordinal. DMF will come discrete, we will go into that one also. So like this, minimal, moderate, severe, unbearable pain. So anything which ranges from progressively increasing and decreasing, for example, anything like ugly, fair, smart, beauty. We can design ourselves, okay? Like which ranges from one end of this one to another extreme. Then it is called ordinal data. Okay. Now coming to the numerical, these two of quality doesn't involve any numbers, numers. Okay. Now coming to this numerical, in this it involves numbers, discrete and continuous. I will tell one simple idea. Okay, discrete doesn't involve any decimal point. Decimal point, I think you know, right? It will come 1 2 3 4 5, anything, like it won't come. But in this scenario, continuous will come with 1.0, 1.2, 1.5, like that, 2.2, anything with the decimal point. If it comes, it will come under continuous value. If there is no decimal point, it is called discrete value. Basically, not only this difference, if you identify with anything with decimal point, it will come under continuous data. Okay, for example, height in centimeter and pocket depth in mm. For example, height in centimeter. For example, that guy is 180 centimeter. It can be 180.2 also, 179.9 also. It ranges, like it comes in decimal point. Pocket depth, same way, similar, like 180.2, 0.5, anything it could come. But if you come to the discrete, whole numerical value typically counts. Okay, for example, number of visits to dentist. DMF we will come later. Okay, number of visits to dentist. Like for example, the guy came to RCT treatment for 5 appointments. We can't say 4.2 appointments, 4.5 appointments. Okay, like that whole number will come. Then it is called discrete. If it is like I told you here, it whole number won't come. 4.2 pocket depth, like that in mm, weight, height, pressure, everything will come under with decimal values and continuous value. Discrete, DMF, like for example, DMF. We know how to calculate DMF, assuming if you know, for example, D could be 2, M could be 3, F could be like missing 3, decayed 2, and filled or restored is 2. It can't be like 2.2 teeth is decayed. It never be like 3.3 teeth is missed. Okay, so these kind of index is called DMF index. Now coming to the continuous, what could be other index can come in this one, like periodontal index, OHA index, okay, can come in continuous data. So now I think it is now clear, I guess. Category or qualitative means nominal, ordinal, discrete and continuous. Okay, in this nominal means name will come, ordinal means only order wise, discrete the whole number will come, decimal point won't come in discrete values, continuous decimal points will come. Okay, so basically these are the type of data. Now coming to the histogram, we should know what is histogram, what basically it represents. Okay, we will go details of this one. So here the answer is continuous. Okay, I will say another one example, like another one shortcuts to remember histogram. Histogram, anything which comes under, you just remember the one terminology in histogram, like frequency. Okay, frequency distribution. Okay, like if for example, if you want to show any distribution of values, best used is histogram. Okay, like for example, I don't know what it X value represent and Y value represent, but what they are trying to say is between 60 to 80 or 60 to 70, whatever it is, there are the values ranges from 5 and it ranges from 5 to 15. Okay, like frequency of distributions. Okay, it's like continuous value. How the graph is continuous without any gap, like this histograms represent frequency of distribution, then it is called continuous value. Now I will explain little more in detail. This is frequency distribution. Another one is bar diagram, what I told you. These two will always get confused. Like it will have gap. This is visual comparison of magnitude different frequencies, discrete data. This represent discrete values. Okay. For example, I will say this one. This is continuous, it is histogram. Now coming to the bar diagram. Okay. This is continuous. This is discrete. I think till this it is clear. Now we will see how it represents continuous data. Okay. I told you to remember frequency distribution. Okay, for age, whenever you see the term histogram, you always remember the term frequency distribution. Only histogram and its variants will have frequency distribution. Okay. For example, in histogram, like I told you, for example, you take blood pressure, diastolic. We take any one value like diastolic blood pressure. It is around 80, 90, 100, 110 and goes on. Here also it goes on. Okay, this is the age group of the patient. For example, this is around 35, 40 female. Whether you can take female or male, their diastolic ranges from, for example, the 40 to 45, the diastolic value, blood pressure value ranges around 80 to 100. This is a gross data. I just, for example, I told you, like it's a frequency, like distribution, whole bunch of people they will say. Now coming to the discrete data, in this one, they will represent each single, like for example, the female or male named X have the blood, uh, for particular age or something, he have around 90. He, he or she had around 100 and 110. Okay, this particular data and 90, 100, 110. It never ever represents the frequency of distribution. It just simply say the particular person, average mean value of this person is around 110, and this guy name is X or Z, whatever it is. Okay, like it's simply seldom, like for example, you can keep it as like it's discrete, like single person, like single person or a group of person or whatever it is, like group of people in a school or something, but it will say only a particular value, but it never tell anything in between ranges, like 100 to 110. These many percentage of people is not there. It can't be said by bar diagram, but in turn we can say like 90 to 100 mmHg. If you want to say any range or frequency distribution, we can use the histograms. Okay, if you don't want to say any range of value, but we want to say any discrete value, we should use bar diagrams. Okay, now coming back to the other types, another one is frequency polygon, another one is frequency curve. Okay, frequency polygon is nothing but like if you say take this histogram diagram. Okay, frequency polygon is what they will do is they will mark middle point of the each cell. Okay, after marking, they just use the scale and draw. They will mark straight line. How it will come again? Like straight line will come. Okay, these kind of data is called frequency polygon. We can use without these cells also. We can use with cells also. Like each thing we have to join. Okay, I think it's clear. Say for example, this is a histogram. They will mark central point and they will use it and join the center point using the scale straight line. If they didn't use the center line and they make it as a curve, straight line, for example, same histogram diagrams, if they mark the same center point, but they used handwritten diagrams or something, then it is called frequency curve. So these two also a variant of histogram. These two also represent frequency distribution. For the sake of representation, visualization, if they use different value, then it is called frequency. This is polygon, another one is frequency curve. If it is straight, it is called, if it is straight histogram, it is called polygon. If it is curved, it is called, this is also represent frequency distribution. Okay, same here also. Now coming to the line chart and graph, I think this is very simple one. Shows trend of events over a period of time. For example, you just remember just like this, anything which we want to relate in relation to time, like month, any month, August to September, this much, and any year, 90s to 2020s, 90s, like anything trend over the period of time, then we will use line chart. This is also simple. For this one, we will use like 90, 100, 110. Then this is 91, 92. This is 1991, 1990, 1992. Like for year they are saying, like this one. Whatever it is, the blood pressure, mean blood pressure, it's increasing for the patient. From 1990 it was around 90, and 1991 it became 100 or 110. Like it is a, like, for the sake of creating, I told this example. But anything, if in relation to time, it is called line chart or graph. cumulative frequency diagram. Simple. The term cumulative, wherever it's called coming, it is called addition. So, for example, they take this itself. Okay, if you're taking this one, draw a cumulative frequency diagram. Okay, then cumulative frequency means how much value. For example, consider this as a year, this as a blood pressure. Okay, for the newborns, the blood pressure will be 40 only. So then we have to find out how many people within the age of 15 is having blood pressure around 90. Then we should draw this line and we have to include and addition the all values here. Then it will come cumulative frequency diagram. So basically histogram, these frequency polygon, frequency curve, cumulative frequency diagram, everything is histogram. It revolves around the histogram. This one is addition of these values. This one is straight line. This one is curved one. Line chart, anything which related to time is called line chart. Okay. Scatter diagram. This is the term whenever you like hear the term correlation between two variables. The correlation, the term if it is coming, it is called scatter or dot diagram. Just keep it, you can buy it also. Like correlation between two values can be best represented by scatter diagram, dot diagram, correlation graph, anything. It's called scatter diagram. Bar diagram, as I told, it is called discrete data representation. Okay. Now coming to the pie or sector diagram. So we all know this one. This is we used to see in news channels and everything. They used to represent this one. Pie, we know that it's a, like a circle. This is considered like, for example, this is the, for example, this pie chart represents the missing teeth in for the mean age of around 50. Okay, this represents caries 75%. For periodontal reason, 10%. For other than the periodontal and caries reason, it is called around 70%, 85, 15%. Okay, so these kind of data like circle, it's called pie sector diagram. Pictogram, like the name itself say, for example, picture. Missing teeth data, molar, they will draw the molar, assume this is a molar, okay, and they will say, and canine, for example, missing tooth data, they want to represent molar, canine, whatever the teeth, they will, whatever the thing, like for example, how much males are there, they will draw the male diagram, how much females are there, they will draw the female diagram, okay, and whatever the thing, they will draw the particular figure and they will represent like this much is 75% people, 50% people, 25% people. Like this, if they draw some particular diagram and explain, then it's called pictogram. For example, missing tooth, molar. For all the missing tooth data, molars captures around 90%. Canines come around 2%. Other teeth like sentinel scissors are coming around remaining 8%. So they will draw a particular diagram, a picture of the thing, and they will represent is called picture diagram. Map diagram, anything which is coming around geographical, like for example South India, North India, they will draw the Indian map and they will represent Tamil Nadu, for example, wealthy state, and for example Kerala, second wealthiest state. Like that, they will say something. Map and spot map, they use the geographical distribution of frequency, then it is called map diagram or spot map. Okay, these are the different type of representations. Now I will say some shortcuts, like again I will say this one, like frequency polygon, frequency curve, and cumulative frequency diagram. Whenever the frequency polygon, frequency distribution, whatever it is coming, it will come under histogram. Okay, basic rule of the solving this question. Okay, histogram. Line chart and graph, I told already. Time, whenever the terminology time in relation to month, time, year, decades, any centuries, then it is called line chart or graph. Okay, then coming to scatter diagram, correlation, whenever you see the terminology correlation, scatter diagram. Bar, I told, it's like discrete data. Pie chart, we know that anything if represented by using a circle, okay, then it is called pie chart. Pictogram, I told, whatever they are representing the variable like for example, if they are taking molar or sentences, whatever they think, like a male, female, I think, if they represent it using picture, it is called pictogram or picture diagram. Okay, map diagram I told geographical distributions. Okay, now coming again to our question. For solving this simple question, we need to know this many data to solve this question easily. Okay, now we know this, we already discussed, it is histogram. So histogram better represent continuous data.